Hi guys, I'm Dinesh Babu. So we are, or I'm going to create a video on SQL Server indexing. So I have a PowerPoint sheet to create or to go in detail. So in SQL Server we have indexing. So SQL Server supports uh, row-based indexing and column-based indexing. So in row-based indexing, SQL Server have clustered and non-clustered index. So this very first point is SQL Server support clustered and non-clustered indexes. SQL Server also support column store indexes. Here we will discuss about only clustered and non-clustered index. So SQL Server column store indexes are from SQL Server 2012 onwards, but we will discuss here only about the clustered and non-clustered indexes. So we have some common features about clustered and non-clustered indexes. So these are the common properties that are followed by clustered and non-clustered indexes. So uh, prior to go dig into detail for SQL Server indexing, I am assuming that the guys of candidate or person should have the knowledge of SQL Server database like SQL Server table querying and how we create indexes. This video is prior mainly for the persons who want to know about the index behavior, how the data is stored and how the data is organized in the B tree format. So I'm assuming the person will have a knowledge of SQL Server table and then joins and then how the table is organized and how so let us discuss about the SQL Server indexing. So SQL both are used for fast data retrieval. So we create clustered and non-clustered index for fast data retrieval. Both have B tree or balanced tree structure. So SQL Server both have that clustered and non-clustered index have balanced tree or B tree structure. Both require additional index storage to maintain B tree. Both clustered and non-clustered index require uh, additional disk usage because it ultimately store the keys or value of the columns on which we are creating indexes, so it require additional disk space. Both have statistics, so because on based off statistics it creates execution plan. So to create execution plan based on statistics, so both have statistics. Both statistics and b-tree structure changes on dml operation. So once we fire insert, update, delete or any dml operation, same time index structure, b-tree structure and statistics get changed. And both perform index scan and index seek based on search criteria, the number of the column in the select list and the where clause or in join clause. Based on that, it perform index seek and index scan. If we have an index on a table or table columns, both have root, intermediate and leaf node concept. So b tree, have a balanced tree structure. So in balanced tree we have root node, intermediate node and then leaf node. So last node is a leaf node. So at the last level we have a leaf node concept. So both can have maximum 16 key columns with index max key column size 900 bytes. So in case of clustered and non-clustered index, we can have, for clustered index we can have 16 key column and non-clustered index 2. And in case of for both follow same limitation. So we can have 16 key column for clustered and non-clustered index, and the column max size of 16 columns should be 900 byte, not more than that, otherwise index will not be created. So these are the some basic difference. Those these So we can have only one clustered index on a table, this one clustered index. We can have more than one non-clustered index on a table. Store the sorted data as per index structure. So in case of clustered index, it at the leaf node it store the sorted data, or we can say at the leaf node it contains the data pages. Here this data pages of the table. But in case of non-clustered index, data is not physically so sorted, and leaf node may contain. So at in case of non-clustered index at leaf level we have three things, that the clustered index key. So if on a table, if we have clustered index, suppose if I have a clustered index and one clustered index and one non-clustered index, so non-clustered index will store the key value of clustered index. So in case of leaf node of non-clustered index, it will store the clustered index key value. And if the clustered index is not there on a table, or means we can say a table is a heap table, means without clustered index, then it will store the row locator or pointer. And all at the leaf level it also store the index key and non-key columns. So in case of non-clustered index leaf node, it stores the index key and non-key column values. So this is how leaf node data is organized for clustered and non-clustered index. And this is the main structure how the clustered and non-clustered index root node, leaf, intermediate node and leaf node are organized. And this is for non-clustered index. Here index id is greater than 0. So for clustered index this is the root node, and this linking is in doubly linked list format, means this is hold the previous node address at this node next node address. So this is in the doubly linked list format. So we can have any number of intermediate labels, and at the leaf node it actually contains the data, but these nodes are also connected through a doubly linked list format. So rows of data. So here is the actual data pages is in the sorted format as per the index structure. We have specified ascending or descending as per that. Data is stored in sorted format. The ascending or descending is not specified, then default is ascending. So this is a clustered index structure, balanced tree structure, and this is for a non-clustered index balanced tree structure. So this is a root node. This is root node where index id is greater than 0, and root node, and then intermediate node we have, and then leaf node. So at the leaf node it actually contains the key value of clustered index on which the clustered index is created. So here it contains the key value of clustered index. If so, data pages is here. Data pages where the actual data is stored. So data pages from the clustered index. But if the clustered index is not there, in that case it will contain the pointer to the data. If also it also store the value of key column and non-key column of clustered non-clustered index. So in case of leaf node of non-clustered index, it will have three things that we already discussed here. So these three things: clustered index key value, row locator if the table is a heap table or a table don't have clustered index, and index key and non-key column values. So here at the leaf node it will contain the key value of clustered index or the row locator or row if the table is a heap table, and key values of the key columns and non-key columns of non-clustered index on which that non-clustered index is created. So this is how non-clustered index is organized in balanced tree format. So let us discuss about the node structure. So root and intermediate node structure. So this is in doubly linked list format. So it holds the previous node value, this holds the next node value, and here is the index row. So index row, here is the specifying next row. So rows address, and this is value like so we will discuss in detail through we have. So leaf node is here. This is the leaf node structure. So the previous node value, next node value, because all the balanced tree is in the doubly linked list format. So this is the rows of data. Here is the at the leaf node. Here we have the actual data in case of clustered index, but in case of non-clustered index it has three value that we already discussed. And now this is the clustered index in structure. So this is the root node. Here we have intermediate node, this intermediate node, and this intermediate, and these are the leaf node. So these are all leaf node. So in the same way this value and row assignment is applicable for rest of the leaf node. So how the cluster index store the data? So here is the value or rows, value or rows. So let us discuss the detail how this tree, balanced tree is organized, how this balanced tree is working, how this balanced tree perform the search, how this balanced tree retrieve the data based on the clustered index or balanced tree structure. So this is the balanced tree of clustered index. So here we have, suppose I have an employee table, and on that employee table I have employee ID and name and address, department, so many columns are there. But let us suppose I have created a cluster index on employee ID. So employee ID, in a table I have a record, suppose I have 20 employee, 1 to 20. So let us take an example of a particular value to search that. So suppose I am looking for 7. Okay, so or 6. So let us take here. So suppose we select a star from EMP where ID, employee ID equal to 6. So what it will do, it will do a comparison over here. So what it will do it, so how it will happen, so let us check diagram view and then design text box. So suppose if I am here and now I'm looking for 6. So 6, what it will do, 6 is greater than equal to 1 because very first value is 1. So 6 is greater than equal to 1, yes it is 1. Now it will go for the second value. Now second value is 8. Now 8, sorry, so 8 is greater than equal to 1, sorry 6 is here, value is 6 and 6 is greater than equal to 1. Now 6 is greater than equal to 8. Now 8 is, so for first it is true but this one is not true because 6 is not greater than equal to 8. So what it will do, it will redirect to this side because the value is stored towards here, so it will redirect here. So 6, now again it will compare, 6 is greater than 1. Now 6, again it will compare, 6 is greater than, yes it is greater than 1. Now 6 is greater than equal to 6, yes 6 is greater than equal to, so it will redirect to here. So again it will compare, 6 is greater than equal to 6 for this value, so it will redirect over here. So it will find the employee detail from this. So this is the actual leaf node or data page where the actual data is stored. So from this 6 it will find out the value. So one value rows, two value rows. So this for one employee ID 1, all the content, it contains all the data. So 1 values or rows, 2 values or rows, 3 values or rows. So this is how all the node of leaf level contains the actual data. Here is the data pages. So from 6 it will pick the values, all the value regarding employee ID 6. Suppose let us take example of 16. Now what it will do, 6 is 16 is greater than equal to 1, yes it is greater than 16 is greater than equal to 8, yes it is greater than equal to 16 is greater than equal to 15 because next value, last value is 15. So yes 16 is greater than equal to 15. So what it will do, it will redirect over here. Now what we will do, we will check 16 is greater than equal to 15, yes because 15 is here, so 16 is greater than equal to 15, yes. Now it will redirect over here. So because 16 is greater than equal to 18 is not, so it will redirect over here, and 16 is greater than equal to 16 for this, yes it is, so it will redirect here, and from this it will find the value for employee ID 16. So this is how balanced tree for cluster index scale or cluster index searching work. So let me delete this. Cut. Okay, that's good. Next, so this is for non-cluster index. So at the leaf node of cluster index, it contains the actual data, value or rows. But in case of non-cluster index, it contains three things: key value of cluster index, If the cluster index is not there, then it will contain the pointer, and it also contains the values for key column and non-key column of non-clustered index. So suppose in a table, if I am looking or searching for suppose if I am searching for C, let us say if I am searching for C is greater than A, yes, C is greater than A. C is greater than H, not. C is not greater than, no, it will redirect here. C is again greater than A, yes. Now C is greater than F, no. So it will redirect here. C is greater than A, yes, C is greater than A. C is greater than equal to C. So it is the comparison operator is greater than and equal to. So C is greater than equal to C, yes. So now it will redirect yes, and from C, now what it will store? It will store the respective value of employee ID. So employee ID, that is for cluster index is created on employee ID. So employee ID is 3. So it will populate, it will find the key value of cluster index. So that is C3. So from cluster index scanning, it will go for the cluster index and browse that cluster index tree and find the value, whatever the value is stored against the cluster index. So C and 3. So 3 is here stored because cluster index, we are assuming that cluster index is created on employee ID and non-cluster index is created on the employee name. So these are the name against employee ID 1 A, employee ID 2B, like that. So this is how the data will organize in case of non-clustered index. So suppose if I am looking for S, so suppose S is greater than A, yes it is. S is greater than equal to H, yes it is. S is greater than equal to O, yes it is greater than. Now it will redirect here. S is greater than equal to O, yes. S is greater than equal to R, yes, S is greater than equal to R. So now it will redirect here. Now S is greater than equal to P, yes. Now S is greater than equal to R, yes. So now it will redirect here, and from S it will find the key value of clustered index, that is 19. Now it will go for the clustered index, and the same way, now what it will do, it will search for the 19 through the clustered index, and from this 19 it will find out the value, actual value, because here is the actual value. But in case of clustered index, in case of non-clustered index, it contains the key value of clustered index and pointer if the clustered index is not there on a table, and key value and non-key value of the non-clustered index columns. So this is how clustered and non-clustered index structure tree, balance tree structure work. So visit and like my blog and Facebook page, that is blog http column double slash dineshbabuverma.blogspot.com, or FB page is Dinesh Babu, that facebook.com slash mssql server dbdba. So this is my Facebook page. So like for more details. Let us check all these through SQL server. So I have SQL server. So I have this employee table. Let us do all these things practically. Okay. So I have employee table. So in employee table, I have I have employee ID, employee name, and department, and then mobile and address. So these are the columns on in employee table, and I have around 11,776 rows. Now check the structure of employee table. So select star from sys.indexes, here object that is object ID of object ID, column in sys.indexes is object ID equal to this. So let us check what indexes we have on this. So we have two system defined tables, those are for indexes. So here we have ID. Now as per a table and this system defined table, we have these three indexes on a table. This is clustered index. So let us drop this index, drop index employee, dot and index name. So I'm dropping because let us do it practically. So and let me drop these, and then so now check what how many indexes we have. No, this is heap table and there is no clustered index or non-clustered index. Now we don't have any clustered and non-clustered. So actually on this table we don't have any indexes. So let us create indexes on this employee table. So how we will create? So let us check the space allocated for this employee table. Sp underscore space used, sp underscore space used. Yes, and now check. So this 11,776 are the rows. Result is total size for the table is this, and this data is this much. Index size is 72 kb and 32 kb. So total is this one. So what we will do, this is the total size for a table without any index. So I will keep it over here, and okay. So this is, here we go. And how create index on employee table. So employee table create clustered index idx clustered employee on employee and emp id. Now I'm creating this clustered index, then we will check how much size is allocated for the clustered index creation. So and then the same point of time what we will do, we will check the space uses for this clustered index. So for this clustered index, so this is without any index. So this size is without any index, and this is with clustered index. Okay, so index size is 240. Earlier it was 72. Now so index size and unused space is 240. Now index size is, and this is always equal to this and this. So three columns data, index size and unused is equal to result. So index size but data size is same, but the index size increased from 72 kb to 240 kb. Now let us create a non-clustered index. So suppose if I am looking for a record from this employee table, select star from employee where okay, check for the column, check for columns. So here emp id equal to emp id equal to 20, anything, any value. So emp id. So see the execution plan. Now cluster index seek is happening because from the leaf node, by scanning this balance tree of cluster index, it is finding the value. So cluster index seek is happening based on the employee id. So here is the idx, this object at the last. See the execution plan. So here is the cluster index seek, and so output list is dvo. So all the columns from the table, and seek predicate. So we are looking value based on the employee id. So last one, see last one, seek predicates. So employee id scalar operator convert implicit conversion this. So implicit conversion this. So this employee id, on the basis of this employee id we are looking for value. So alt F1, check the table structure. So this this is our table structure on. So address is varchar 800 and then move on. So this is, now let us create a non-clustered index on emp name table with which varchar 100. So create non clustered index on employee underscore ename emp name emp name. So let us create, and we will see the space allocated for non-clustered index. See, earlier it was 240, from 72 to 240 for clustered. Now with non and with clustered and non-clustered index. So here this time we have clustered and non-clustered index. So index size is 608. But for this allocation, it will what it will store? It will store the value for employee name. Also at the leaf node, it will store the key value of clustered index. So employee ID and employee name will be stored at the leaf node of this non-clustered index, that is idx employee underscore emp name. So this here it will store what it will store, the value of clustered index, key value of clustered index, also the key value of non-clustered index. So this is how. Now let us check further. So we have included column, so we have covering index, and then so in a query we are using number of columns, multiple columns. So if I want to search all the record from that query, all the columns from that query, so we can create a covering index. So we will see how the covering index works, how the space allocations happen. So let us create so one thing I want to show you. So let us see how the execution plan is working. So what we will do, select star emp name equal to, earlier it was employee id, wait, emp name emp id. Okay, now check Larson, and then this. So it clustered index seek is happening because on the basis of employee, and now I will search for basis on non-clustered index key column. So non-clustered key column is employee ID, employee name, sorry. So employee name, select star from employee where employee name equal to Larson 30. So now check execution plan. So index seek and key lookup. So key lookup, because seek is for this employee ID and key lookup is because at the leaf node, at the last node, it also store the key value of cluster index. So key lookup based on the cluster index key value. So key lookup happens because it finds at the leaf node of non-cluster index key value of clustered index, and then it is going for the key lookup because it again is scanning the clustered index. So key lookup, this seek predicates employee dot employee id. So key lookup is for employee id. At the leaf node, it is finding the value of key value of clustered index. So this is seek and key lookup. So key lookup and seek and index scan also happens based on the number of record that we are searching. So if in a select query or in a query, if the record are very high, then it won't go for seek and key lookup, it will go for index scan, because based on the number of record, qualifying record for a query, it find out the record. So index seek, key lookup, and now we can check this practically. So suppose Larson Allen. Now, so in this table I have a column Allen. So Allen. So what we will do? We will search the same column. Value is different. Now, earlier the record was for Larson was 1. Now Allen, based on Allen. Seek. Now see the execution plan. Now clustered index scan. because the row selectivity is very high. But now for Alan we have 4,000 rows out of 11,000 something record. So 4,000 record we are getting. So instead of go for index seek and then key lookup, it is going for the cluster indexing. So cluster index scheme. So execution plan. So optimizer decide the best execution plan. If best execution plan is not there as per the query qualifying row, it create a new execution plan. So now the execution plan, in the execution plan we have clustered index scan. Okay, so now if I search, so for this, so suppose if I search here this only, now cluster index seek, because at the leaf node it store the value for emp name, because we created this. So from the index itself it is picking the value, so that's why here it is index seek. Now if I specify any other column, suppose employee table, so suppose rest node, suppose dept id. Okay, so if I find the dept id, check for the dept id also, so it won't find the dept id in the index, because the index is created on emp name and employee id, but dept id is not there. So because of the dept id new column, because this is not a part of any index, so it will go for clustered index scan. So this is how the execution plan changes. So suppose this is happening for this errand, but now let us check for other records. So this is last one, so here it is seek, because based on that key of clustered index we are looking. But now check for this last chapter. So here we have one record, right? So how many record? This, but dept id is not part of any index. So here is the seek and key lookup. Key lookup, because the seek is for this employee 30, because seek, and now from 30 it is finding the key value of cluster index, that is key value of the cluster index is emp id. So let us see what is key value of cluster index 30. So from leaf node of non clustered index it is finding the 30, and based on that it is performing key lookup and going for the clustered index scan and then finding the dept id. So this is how clustered and non-clustered index work, and how the execution plan work. There are so many features, there are so many options, there are so many hints to perform, or for the execution plan to create, for the optimizer to create an execution plan. So based on those criteria, based on those options, it create execution plan. So what we will do, let us check one thing, one important thing, how it is really stored data pages at the cluster index. So what we will do, so employee, this is the employee table, one thing, this is most important thing what we can verify. So here address is varchar 8000. Okay, now the record in this, is, so this is, now what we will do, employee, now we will drop these indexes. So drop index, employee dot this, I'm dropping clustered index from this employee table. Now looking for this, earlier it was seek, because here department id and the key lookup was there, right? So now rid lookup, because the seek is happening, seek is fine for the seek is fine for this based on the non-clustered. So employee name, that employee name is there, this index is there, but now cluster index is not there. So instead of key lookup, now it is going for the rid lookup. Now it is going through the pointer to find out the value for the department id. So department id is there, employee id is there. So again, so this will also go for the employee id and department id, because department id and employee id is now not the part of any index. So it will go for the RID lookup, row ID lookup, row identifier. It is using row identifier. So to find out this row identifier, it also use extra 8 byte per row. So this is how the this is how the space allocations happen. So in case of heap table, so this is a heap table because cluster index we have dropped. So when we are searching record based on non-clustered index, so it is using the pointer from the leaf node of non-clustered index to identify the record. So this is using RID lookup or row ID lookup or row identifier. We can see for this it takes extra 8 byte. Now what we will do, we will drop, we will create a clustered index on ADDR column. ADDR. ADDR is very huge column. So in the huge, this is address, that column is around 8000. So 8000 character and characters, where 8000 is size. So I am creating clustered index on this. Now clustered index column address does not exist in the target table ADDRS. Sorry. So clustered index on a table. Now let us see if we can create clustered index. So let us see, maximum key length is 900 bytes. So 900 byte, this is what we have discussed in this PowerPoint sheet. So here the maximum, yes, so maximum 16 key column with index max size, column size is 900 byte. So here what we are getting, warning, the maximum key length is 900 byte. The index, this having maximum length of 8000 byte. So because 8000 is the for employee that address, so where 8000 is, so for some combination of large value it won't, so this is means, so operation failed, the index entry of length 6583 bytes for the index this exceed the maximum length of 900 bytes. So index is not creating. Now what we will do, we will create this index on some other column. So some other column, so what we can do, we can, so let us create this on employee ID, EMP ID. Let us play around indexes, how the index scan, see, RID lookup, key lookup. This is always be a question, what exactly, how it is happened. So now the size will be same, but now I'm creating again one more non-clustered index based on some other column. So include what, ADDR can be a part of non-key column for, so non-clustered index. So now I'm creating this non-clustered index on DEPT ID and DEPT ID and underscore ADER. Yes. Okay, so F5. Now I'm creating this non-clustered index on department ID with include clause of this. Now, as per our understanding, as per our discussion till now, the size of index should be very high because it should store the key value of non-clustered index, that is this department ID, and non-key value of non-clustered index, that is ADDR. ADDR is 6000, more than 6000, or in the next size is varchar 8000. So size of table should be very high for this table. So let us check the space used with one more additional index, and so with the header. Now as per our discussion till now, size should be, you see the size is, now the data, earlier data is same, but that now the index size is 95000. Earlier it was 600 byte, 600 kb, 608 kb. Now index size is 95152 kb. So see the how the size get increased, because at the leaf node it stored the value for department ID and ADDR. So this is with the clustered and two non-clustered indexes. So you watching this example, these example or size allocation, we can see how the index or tree, balanced tree is organized, how the index allocation, size allocation happens, because here earlier it was 608, now it is 95152 kb. So there are so many things. So this is all for today. So this is how the index organized or how the index behavior happens. So everything optimize, decide, create execution plan based on the number of record or the index column usage in the query, in the join clause, where clause, or in the select clause, or group by clause, or order by clause. Everything it takes and perform, create, or have find out a best execution plan, and based on that it goes to the database engine and then find the record or fetch the record. So in nutshell we can say we create indexing for the fast data retrieval, so that we don't have to wait, and this is just like as a index that we have in a book. So this is all for indexing. And then so also one more thing we can consider, so that cluster index should be on a very small column, because the cluster index key value is stored at the leaf node of the non-cluster index. For every non-cluster index, like suppose in a table I have 10 non-cluster index, then 10 non-cluster index will store the key value of cluster index. So cluster index key value should be as small possible. Even though if we have duplicate value in the cluster index, then it use the unique identifier. So for that it allocate 4 white for each row to uniquely identify the duplicate record. That is good, but comparing to create a cluster index on a huge column, that varchar 60 or varchar 100 or varchar 80 or 200, so we should always create a cluster index first on a small size column data type like integer, small int, or because every non-cluster index store the key value of cluster index, and non-clustered index should be as less as per the query search criteria, or as per our stored definition as per our query. So we should have at least one clustered index, and then we can have any number of non-clustered index. So this is all for today. So in next we will go dig, or we will dig in detail for the clustered or non-clustered index structure, how and when, how the execution plan work, and what execution plan work, what execution plan displays. So this is for today. Thank you guys, thank you for watching this video, thank you very much. So this is let me stop my video. Yes.